All right, we're on problem 113. 113 on page 287. So they've drawn this thing. Let me see if I could draw it. So it looks like they have a right triangle in the center. That's one side, that's the other side, and then the base. It's right triangle. And then they drew some squares on every side of that triangle. Let me see if I can, how well I can do that. So one square. Well, I don't know how I'm going to draw the other square because I don't know how to draw an angled one. I'll have to just draw the lines. The other square. And then the last one, I'll just draw out some lines. Looks something like this. Comes off like that. Like that, and like that. So that's what they have. And they call this A, this B, C, D, and they tell us that this is a right angle. They say in the figure above, if the area of triangular region D is 4, so the area of triangular region D is equal to 4, what is the length of a side of square region A? So we need to know the length of the side of square region A. So all of these are, let's see, all of these are, well, they don't tell us that this and this are a square region just yet, but they tell us this is a square region, right? So the length of this side, if we know the length of this side and that side, then we can figure out the length of the hypotenuse of this right triangle. So that's all we need. And let's see, if we let's call this length right here, let's call this little b. And let's call this length little c. So we already know that little b, if we know the area of this triangle is 4, we know that little b times little c, so height times base times 1/2 is equal to 4. Or that also tells us that little b times little c is equal to 8. I don't know what that does for us. Let's read the statements. Statement number 1. The area of square region B is 9. So B is equal to 9. Well, that's useful, right? If the area of this region, and it's a square, is 9, what's each of the sides going to be? The side is going to be the square root of that, right? Little b is going to be equal to 3. Right? If little b is equal to 3, then the area of this is 3 times 3. We can do that because it's a square, which would be 9. So if little b is 3, then what is c? Well, then we get that c is equal to, what is that, 8 over 3, using this information. And we got that, remember, just based on the fact that the area of this triangle right here is 4, right? So little b times little c times 1/2 would be equal to 4. So if we know what little b is and we know what little c is, then we can solve for, let's call that little a. And little a is what the whole point was about. What is the length of a side of the square region A? So we could just solve for, b squared plus c squared is equal to a squared, right? This squared plus this squared is equal to the hypotenuse squared. And we just solve for a and we'd be done. So statement 1 alone is sufficient. And this is really messy, especially taking an 8/3 squared and all that, so I'm not going to do it, and it would be a waste of time on the GMAT anyway. Let's look at statement number 2. Statement 2. The area of square region C is 64 over 9. So C is equal to 64 over 9. So this is kind of very similar to the information they gave us in statement 1. If the area of this is 64 over 9 and this is a square region, then the length of each of its sides, or in this case little c, the length of little c is just going to be the square root of that. So little c is going to be 8 over 3, which is exactly what we figured out here. And then we could use this information that we got from the problem statement that b times c is going to be equal to 8. And we got that from the fact that the area of this triangle is 4. So we use that and we can figure out that b times 8/3 is equal to 8. And then you get b is equal to 3. And then you apply this again. So and to solve for a. So each of the statements, 1 and 2, are each individually sufficient to answer this question. Next problem. 114. If x is to be selected at random from set T, what is the probability that, so they want to say, what is the probability that 1/4 x minus 5 is less than or equal to 0. Let's simplify this real fast. That means that what's the probability that 1/4 x is less than 5? And that means what's the probability? Let's multiply both sides by 4. I just added 5, both sides here. And let's multiply both sides by 4, and we don't have to change the inequality since 4 is a positive number. So it's the same thing as what's the probability that x is less than 20? And I like this a lot more because it's just simple and it lets my brain grasp the problem better. Now what are the statements they give us? Statement 1. T is a set of 8 integers. T has 8 integers. Has 8 integers. That by itself doesn't help me because I don't know what those 8 integers look like. I mean, maybe all 8 could be larger than 20, in which case it would be impossible to find one that's less than or equal to 20. Or maybe all 8 are less than 20, in which case you would have a 100% chance. So statement 1 by itself is fairly useless. Statement 2. T is contained in the set of integers from 1 to 25. T is contained in the set of integers from 1 to 25. So that also doesn't help me. So T within 1 to 25. So they're essentially telling us that every number in T is between this range. But if we just take statement 2 alone, they're not telling us, first of all, how many numbers are in T. Statement 1 tells us that, but statement 2 tells us. And then even if we knew how many numbers were in T, we don't know where they're distributed. Maybe all of the numbers in T are less than 20, in which case there's a 100% chance that you would select one that's less than 20. But maybe 4 of them are greater than 20, right? Maybe we have 21, 22, 23, 24, and 4 of them are less than 20. Or maybe something in between. So given that, you still don't know where T is distributed relative to 20. So I say that we still don't have enough information, even with both of these statements, to solve this problem. Next question. 115. It takes the most confidence to choose that E, to say that one cannot solve this problem. 115. I'm always second guessing myself. I'm like, well, I'm going to make sure I haven't missed some piece of information. No, but I'm pretty confident here. All right, 115. If Sarah's age is exactly twice Bill's age, so Sarah's age is twice Bill's age, what is Sarah's age? So they want to know Sarah's age. S for Sarah's age. Let me scroll down a little bit. Problem statement number 1 says, 4 years ago, Sarah's age was exactly 3 times Bill's age. So Sarah's age 4 years ago, so Sarah minus 4. S is Sarah's age today. So Sarah minus 4 is exactly 3 times was exactly 3 times Bill's age. So was 3 times Bill's age then. So B minus 4. Right? Sarah's age 4 years ago was 3 times Bill's age 4 years ago. Fair enough. So just with this and this, can I solve for S? Well, sure. I have 2 linear equations and 2 unknowns, so I can solve for either variable. And to prove it to you, I'll do it. Although this, once again, is a waste of time from the point of view of the GMAT. S is equal to 3b minus 8. And then b, from there we get b is equal to s over 2. So s is equal to 3. Right, I just divide 2 into both sides. So 3s over 2 minus 8. What can I do here? So I have 1.5s. I can subtract it from both sides. So I have minus, I'm doing it fast, just to minus 1/2 s is equal to minus 8. And then multiply both sides by minus 2, and you get Sarah is 16 years old. And you're done. But you didn't have to do any of this. That was all a waste of time. You just had to see that you had 2 linear equations and 2 unknowns, which is enough to solve for either of the variables. Statement 2 tells us, 8 years from now, Sarah's age will be exactly 1.5 times Bill's age. So same thing. Sarah's age 8 years from now is going to be equal to 1.5 times Bill's age 8 years from now. Same thing. We have 2 linear equations, one that they gave in the problem statement and one they gave in statement 2, and 2 unknowns, no reason why you can't solve for both variables. And you might want to do it for yourself just as an exercise, but you would do it the same way you did it right here. I always find substitution to be the easiest, especially when one of the equations is really easy to manipulate. Next problem. So each statement individually is sufficient to solve this problem. Next problem. 116. Oh, I just realized I'm out of time. I'll do 116 in the next video. See you soon.